Hey everybody, I wanted to hop on here and do a video for section 2.2, and I'm also going to do a video for section 2.3, but let's start with 2.2. I started writing some of the highlights. So if you go to Canvas, you should be able to see a handout just like this one that is blank. I uploaded the blank one, and then once we go through this video, I will upload also the one that is filled with everything that I say. So the highlights of section 2.2 are the slope. The slope of a line gives you the rate at which the line is changing, increasing or decreasing. So the slope, we usually say, is the change in y over the change in x. And so sometimes you see the little delta, that means change, so you have the change in y over the change in x. Meaning that if you have 2 points, right, so if you have x1, y1, and x2, y2, the change in y is the difference in the y values. So you're going to have y2 minus y1, and the change in x is the difference in the x values. So x2 minus x1. Doesn't really matter which point you start with, but you have to be consistent, right? You can also say x, not x. We don't want to say x. Change in y is not x. So we're going to say y1 minus y2, or x1 minus x2. So it doesn't have to be the second point minus the first point, but as long as you're consistent. So if you start with y2, you have on the top, you have to start with x2 on the bottom. If you start with y1 on the top, you have to start with x1. Essentially, stay consistent. If you start with this point, do it for both, the x and the y. If you start with this point, do it for both. The equations of a line, usually you'll see it in what's called the slope y-intercept form, and this is your y equals mx plus b. So you may be used to seeing lines like this, right? For example, you can have something like y equals 2x plus 1. So that means the slope is 2 and the y-intercept is 1. Sorry, the y-intercept is 0, 1. Usually you want to give the y-intercept as an order pair. So x is 0, y is 1. And the other form of the equation of a line is the point slope form, which is y minus y1 equals m x minus x1, right, where m is the slope and x1, y1 is a point on the line. Any point. It doesn't have to be the y-intercept. So the previous one, you're given the y-intercepts. Your one here, x1, y1 doesn't have to be a point on the, it doesn't have to be the y-intercept. It's just any point on the line. And the other thing we're going to talk about are parallel and perpendicular lines. Parallel lines, when you hear the word parallel, what comes to mind? Hopefully, so for example, if I have y equals 2x plus 1 from that example, the y-intercept is 0, 1, so it's going to cross here at when x is 0, y is 1, and the slope is 2. The slope being 2 means I can write it as 2 over 1, right? The rise over the run. That's another way you've heard the slope probably. Instead of changing y over changing x, you may hear it as rise over run. So this tells me the rise is 2 and the run is 1. So from my y-intercept, I'm going to go up to the rise, right? The change in y is 2 and the run is 1. So up 2 and over to the right 1. So that will be the point, where was I? 0, 1. So we were at 1 on the y, so we're going to go 2, 3. And we were at 0 on the x, and we moved over to the right 1. So this new point is the point 1. You always write the x value first, 3. And any 2 points determine a line. Now if you want to be a little more accurate, you can find a third point to go down. So the change in y is 2, the rise over the run, but if I want to go down, it won't be the rise anymore, or you can think of it as a negative rise. So it will be, I'm going to go down 1, down 2, and over to the left 1. And so this will give me a nice idea what my line is looking like, right? And then what point will this be? Well, from 1 we went down 2, so it'll be 0, negative 1, and this is not drawn to scale, and then to the right, to the left 1 also, so it'll be negative 1 as well. So this will be the point -1, -1. So a line parallel to this means it follows the same incline that this has. So a line parallel to this one will be something like that, as long as it has the same shape. Well, I drew it a little bit different. Art is not my strong suit, but pretend these are parallel. So parallel means that they're never going to intersect. So the green lines will never intersect the blue line. So these lines are parallel. So parallel lines never intersect. They have the same rate at which they grow, at which they move, which then the rate of how they move is the slope, right? So that means that parallel lines have the same slope. Now perpendicular lines, things are perpendicular when they make a right angle with each other. So a perpendicular line is going to essentially come to one of these, to all of them really, at a 90-degree angle. So if I continue that line, so the black line here, this line is perpendicular to y equals 2x plus 1. So perpendicular lines cross at a 90-degree angle. So they meet at 90 degrees. So notice that because the other ones, the green ones, are parallel to the blue one, those will also meet the black one at 90-degree angles, and so that makes them perpendicular. So that means everything got rotated 90 degrees. Now think about, if you look at the x and y coordinate range, what happens if you rotate the x-axis 90 degrees? The x-axis becomes the y-axis, right? And what happens if you rotate the y-axis 90 degrees? If you rotate the y-axis 90 degrees, becomes the x-axis. So essentially, as you rotate something 90 degrees, the x and the y-axis swap places. So if you think about this blue line, if I rotate it 90 degrees, I get the black line, and so that's what makes them perpendicular. But that also says, remember what I said, that the x and the y values switch places. So the perpendicular lines, your x's and your y's on the slope are going to switch places. So the slope of a perpendicular line is the reciprocal of the original slope, because the x and the y switch places. So I'm going to say, so how do you say perpendicular? So let me remind you. Reciprocal, sorry. So a little review on reciprocals. If I have 1/3, what's the reciprocal of 1/3? Is going to be 3/1. right? What's the reciprocal of, say, 2/5? The reciprocal will be 5/2. And so here, for our original slope, is m. Original slope equals m, so the perpendicular slope will be 1/m, right? Just like we did here. So the reciprocals, if you have a whole number, the reciprocal of, well, let me try the one that we did here, right? The slope here is 2, so if m equals 2/1, the perpendicular slope is 1/2, 1/2. This little upside down t is the symbol for perpendicular, so you may see that often. So, but I'll come back to perpendicular lines and parallel lines. Let's do an example of finding slope and finding equations of lines. So find the slope of the line through the points 5, 0, and 2, 6. So for this one, first let's remember our formula. So the slope is rise over run, which is the change in y over the change in x, y2 minus y1 over x2 minus x1. So it doesn't matter which one you choose, so I'm going to start with that one. So it'll be 6, right, the y, so if you call this x1, y1, and this is x2, y2, then following this formula I'm going to have y2, 6, minus y1, 0, over x2, right, since I started with that point, x2 is 2 minus x1, which is 5. So I'll have 6 over 2 minus 5 is negative 3. And now I need to reduce this. 6 goes into, or 3 goes into 6 2 times. So my slope is minus 2. The second example, find the slope between these 2 points. So the slope again will be y2 minus y1 over x2 minus x1. So I'm going to say 11 minus, now I have minus and minus, so 11 minus a minus 2 over negative 4 minus a minus 5. So minus and minus becomes plus, so I really have 11 plus 2 over negative 4 plus 5. 11 plus 2 is 13, negative 4 plus 5 is 1, so the slope is 13. Now I want to do an example where you switch them, right? Like I said, it doesn't matter which point you start with, you just have to be consistent. So if I start with this one, with my first point, so this will look like minus 2, right? You start with the y, minus 11 over, so since I started with minus 2 on the y, I have to start with minus 5 for the x. So minus 5 minus a minus 4. So minus 2 minus 11 gives me negative 13, and negative 5 minus a negative 4 gives me negative 5 plus 4. So I get negative 13 over negative 1, which is negative divided by negative is positive, so I get 13. Same thing. So it doesn't matter which point you use first, you just have to be consistent. Now one of the things I want to point out is that when the slope is negative for this one, if you plot the points, right, the point here was 5, 0, so 1, 2, 3, 4, 5, 0, 5 to the right, and the y didn't move, so you stay on the axis, and the other one is 2, 6, so 2 on the x, and then 6 on the y, 1, 2, 3, 4, 5, 6, so somewhere up there. So when you draw the line, it will look something like this. So notice that then as you look at it from left to right, the line is decreasing, the y values are getting smaller. So a negative slope means your line will be decreasing from left to right. You always, in math, you always read things from left to right. Notice for this one, the slope is positive. These might be harder to plot those points, especially in this space I left myself. But the slope is positive, so this line will have an increasing direction. So -5 -2 is going to be not necessarily drawn to scale, but it's going to be somewhere over here. And then -4 11 is going to be somewhere up here. So notice that this one, as you look at it from left to right again, you always look at things from left to right, it's increasing. So a positive slope means it's increasing, and negative slope means your line is going to be decreasing. Now let's find an equation of the line having slope 1/2 and y-intercept of 0, 5. Since the slope is positive 1/2, what do you anticipate this line is going to look like? Right, it should be increasing. The slope is positive, so it will increase. So to graph it, what I can do is I can say, well, I know my y-intercept is 0, 5. Y-intercept is where it crosses the y-axis. So I'm going to go x is 0, y is 5. So there's my y-intercept, 0, 5. And the slope is 1/2. So m equals to 1 over 2. Remember, the slope is rise over run. So that's the rise and that's the run. So that means I'm going to go up 1 and over to the right 2. And I can keep going this way, up 1 and over to the right 2. I can also go the other way, and instead of going up and to the right, I'm going to go down 1 and to the left 2, down 1 and to the left 2, and that creates my line. But we were asked to find the equation of the line, but I just wanted to graph it as well to show you that. Now look at it as you read it from left to right. As you look at it from left to right, it is increasing. The y values are getting larger. So makes sense because the slope is positive. Now to find the equation of a line from the first page, we know two ways. We have y equals mx plus b, and the other one, the point slope form. So let me bring that back to show you. These are the two equations of the line. So we're going to use the mx plus b form since we have the y-intercept. Right? We know y equals mx plus b. We're given m is 1/2, and the y-intercept is 0, 5. So that means that b equals 5. The y value of your y-intercept point is the b. So I can go and say, okay, y equals m 1/2 x plus b, and that's it. So if I have the y-intercept, finding the equation of a line is pretty nice. Sorry. What if we don't have the y-intercept? I find an equation of the line containing those points, and again we can quickly graph it. Right, -1, x is -1, y is 1, and 2, 5. 1, 2, 3, 4, 5. And I usually like to graph my lines just so that I know what kind of slope I should get. As I look at it from left to right, what is this line doing? The y values are increasing, so I should see a positive slope. So if I don't get a positive slope, I need to be concerned. So if I want to find the equation of this line, I can use either y equals mx plus b, or I can use y minus y1 equals mx minus x1. Notice that it doesn't matter which one I'm going to use. For both of them, I need to find the slope. So let's go ahead and find the slope. So the slope is rise over run, the change in y over the change in x. So doesn't matter which point I start with. So I'm going to use 5. So 5 minus 1 over, since I started with 5, I have to start with 2. 2 minus a minus 1. So what's that? 5 minus 1 is 4. 2 minus a minus, so that becomes a plus. So 4 over 3 is the slope. Okay, so we have the slope. Now what? Remember, we needed the slope to be able to put it back into one of those. So I'm going to do it both ways. And it's up to you. I'm never going to ask you to find the equation of a line one way or the other. I'm just going to say find the equation of a line. So it is up to you to use the one that you feel most comfortable with. So y equals mx plus b first. So I don't have b, so what I need to do is pick one of those points in my slope and find it. So I'm going to use, I don't necessarily like negatives. Sometimes negatives can be confusing, so I'm going to use the slope is 4/3, and I'm going to pick the point that's positive. So into, and substitute into y equals mx plus b. Right, so substituting, that means that y is 5. So I'm going to have 5 equals m is 4/3. 4/3 x. X is 2 plus b. So when I do it this way, I need to find b. So I'm going to have 5 equals, this is like 2 over 1, so 4 times 2 is 8, 3 times 1 is 3, plus b. And how do you solve for b? We need to subtract 8/3. So I'm going to have 5 minus 8/3 equals b. Alright, some of you may want to see this done. Subtract 8/3 from both sides. Here it cancels, and here you have 5 minus 8/3. So that's what b equals. So let's put a 1 in there, and let's find a common denominator. Common denominator is 3, so b is going to be, so multiply bottom by 3 and the top by 3. So 3 times 5 is 15. So, and that makes sense. 15/3 is 5 minus 8/3. Sorry, I'm kind of going backwards here. So 15 minus 8, what's that? 7. So 7/3 is b. So the equation of the line, so my final answer will be, right, y equals mx plus b, which now I have what I need. Y equals m, which we found it above, 4/3, plus b, which I just found it, is 7/3. And so that's one method. The other method, I wonder if I can squeeze it in here. I better not try. The other method is using the point slope form. So using y minus y1 equals mx minus x1, I'm going to have, we know m is 4/3, and I'm going to use the same point, which was 2, 5. So in this case, we substitute, this is now my x1 and this is my y1 in the formula. So what this looks like is y minus y1, which is 5, equals m, the slope that we found from before, 4/3 x minus x1, and x1 is 2. And we solve this. So I have y minus 5 equals, distributed in 4/3 x minus 4 times 2 is 8, 3 times 1 is 3. And now I want to get the y by itself, so add 5 to both sides. Here it cancels and I'm left with y equals 4/3 x minus 8/3 plus 5. Get a common denominator, which is 3, so 15/3. Which notice is the same math we did earlier. So 15, or negative 8 plus 15 is positive 7, so 7/3, which is the same answer we got the other way. So again, it is up to you. Oh, I forgot the x there. Good thing I brought this paper back. Yeah, so either way, we get the answer is 4/3 x plus 7/3. Using y equals mx plus b, or using the point slope form. So it's up to you which one you're going to prefer. Try it on the homework and see which one comes more naturally to you. I prefer the point slope form, but that's because sometimes I forget to go back and solve for b. So sometimes I just find the slope, and this one sometimes gets confusing for me, but again, that's personal preference. It's going to be up to you to see what you'll like to do. Okay, so to talk about parallel and perpendicular lines, I'm actually gonna, this video is getting a little long, so I'm gonna combine this one with section 2.3. So let me stop this video here, and then my next video will start with parallel lines, perpendicular lines, and then we'll move on to section 2.3, which is linear models.